Welcome guys to a series of videos on sound waves. These are set of 3 videos on sound waves and they completely explain all the basic understanding with respect to sound, like how are sound waves formed, what are characteristics of sound waves, how is loudness of sound different from pitch of a sound, and what is timbre. They also explain the relation of frequency, velocity and time period. Also, this set contains the phenomena of diffraction and sound spectrum at the end. I have also included examples to make the concept more thorough. Also, these videos are much different than my earlier videos. So, do stick till the end. For now, let's get started with sound waves part 1. So, now let's understand how is sound produced. Sound is produced when air in contact with the vibrating body suddenly compressed. So this is the vibrating body, the speaker, and this is the listener. The listener is able to hear this sound because the air molecules here are compressed. So sound is produced when air in contact with this vibrating body is compressed. And due to the elastic nature of medium, these compressions spread away from the source. So what happens, because the air is an elastic medium, whatever compression happens here, that is slowly spreading away from the source and it goes towards the destination, that is the listener. Now what medium exactly? Medium can be any medium like liquid, any liquid medium. It can be gas or it can be any solid. But medium is must for sound waves to propagate. And elastic nature means what? Elastic medium is a medium that can be deformed due to the deforming force applied and regain its original shape when the deforming force is removed. So here the deforming force is the vibration coming from the speaker. So what happens when the speaker is on, the air molecules in the medium are compressed and slowly those vibrations are being transferred from particle to the neighboring particle. These particles vibrate along the direction of propagation and these are transferred to the immediate next particle. So that is how the vibration is transferred and it is reaching the listener. It is, you need to understand, it is the particle that is vibrating and it is not the displacement of the particle to a new position. So particles are there itself, the air molecules are there itself, they just vibrate around their mean position and come back to their original position, and in the process they transfer their energy, vibrational energy, to the neighboring particle. Then neighboring particle will transfer the energy to the next neighboring particle. And that is how these compressions are spreading away from the source and reaching the destination. We also need to remember and understand that sound cannot travel through vacuum. Sound always requires a medium. Sound cannot travel through vacuum. That is why we have it. It can always travel through any liquid, through any solid or through any gas, but it cannot travel through vacuum. Like light waves or electromagnetic waves, they can travel through vacuum, but sound waves never travel through vacuum. Now the vibrating body, that is this speaker, sets up waves of compression and rarefactions in the air. So what happens, whatever air is compressed here, these molecules, then air molecules, then transfer their energy to the neighboring particle and they come back to their original position, ordinary position, whatever was before the vibrational wave is happening. So these particles then transfer their energy to the neighboring particle and that is how the compressions are proceeding. So in between two compressions we have rarefaction. That means here the particles are farther away from each other. Now during compressions the particles come close together, hence pressure increases, while during rarefaction the particles go away from each other, hence pressure decreases, and this is how a pressure wave is formed in the medium. So what happens here is wherever there is compression, the air molecules come closer together, because of which the pressure increases in this region. And wherever there is rarefaction, the particles are away from each other and here the pressure decreases. So pressure wave is formed. Now where it is basically sound is a pressure wave. So pressure, or we say pressure disturbances. So here maximum pressure, here minimum pressure, maximum pressure, minimum pressure. Like this the wave continues. So whatever compressions are there, that region, the particles are closer together, which increases the pressure, and the region where particles are away from each other, the pressure decreases. Hence we have such type of wave being formed. So this is how you can see the wave compressions. So this is a wave, this is a pressure disturbance in the medium. Compression means high pressure, rarefaction means low pressure. As these particles vibrate parallel to the direction of the propagation, hence these waves formed are called as longitudinal waves. So sound waves are longitudinal waves because these particles vibrate to and fro along the direction of propagation of the wave. Please do refer to my video on waves and its types. I'll be putting the link in the description box. Please do go through that video. It will give you a detailed idea of longitudinal waves, how these waves are formed. And along with longitudinal waves, there are transverse waves. So what is the difference between longitudinal waves and transverse waves? That video will make it more clear. So basically the pressure waves reach our eardrums to give us the sensation of hearing. So now what can we say? Sound waves are pressure disturbances. So this disturbance is the pressure disturbances in the medium. This is very important. It is in the medium caused by energy traveling away from the source of sound. And what form of energy is it? It is the vibrational kinetic energy. The particles are moving. So it is particles are moving to and fro. So it is vibrational kinetic energy. Please once again do refer my video on waves and its types. Now let's understand characteristics of sound waves, or what are the terms that are used to describe a sound wave. By now we have understood that sound wave is a pressure disturbances like this. It is a pressure disturbance. So now we need to understand what are the different terms that are used to describe a sound wave. So here you can understand it is basically pressure disturbance. So it is a wave which is with respect to on y-axis we have pressure, on x-axis is time. So how the wave is traveling, pressure wave is traveling with respect to time. And these are the regions of compression and rarefaction. Now we need to understand this one cycle is called as one wave. Okay, so this one cycle, one compression and one rarefaction, adjacent rarefaction makes one wave. This you need to understand. Now displacement from the mean position. Particles are initially in their mean position, and now when the vibrational object is there, this particle will move away from its mean position, and how much maximum distance the particle can travel, that becomes the amplitude. So we'll have first term wavelength. Wavelength is the distance between the centers of two consecutive compressions or two consecutive rarefactions. So it is the distance between two consecutive compressions or two consecutive rarefaction. This distance is called as wavelength, and the symbol for this is lambda. This is called as lambda. Or I can say distance between two rarefactions is 1 lambda or 1 wavelength, or it is also said as the minimum distance in which the sound wave repeats itself. So this one cycle compression, one cycle rarefaction. Now further if it proceeds, it becomes a compression. So minimum distance in which the sound wave repeats itself is called as wavelength, lambda, 1 lambda. The distance between the centers of the compression and an adjacent rarefaction is equal to half of its wavelength. So this distance between the center of the compression and the immediate next rarefaction, this will be lambda by 2. And SI unit of wavelength is meter, because it is a distance that we are measuring. So the SI unit for wavelength is meter. Now next term, amplitude. Amplitude is the maximum displacement of the particles of the medium from their original undisturbed positions. So once again, now this is maximum displacement. So SI unit of amplitude is also meter. Maximum displacement from the undisturbed position. Original undisturbed position is this. Now a vibrational object is there, because of which the particles start vibrating and the particles move away from their original undisturbed position. The maximum distance they can go, that is the amplitude of the wave. So displacement from the mean position is the amplitude. Now next is time period. That is time required to produce one complete wave. One complete wave. So how much time is required to produce this wave? That is called as time period. And one complete wave is produced by one full vibration. Now one vibration means one wave. Particle is initially in an undisturbed position. Now because there is a vibrational energy, so it will start moving or oscillating to and fro and then again come back to its original position. So this makes one wave or one cycle. Hence it is the time taken to complete one vibration. Unit of time period is seconds. Next is frequency. Frequency is the number of complete waves or cycles produced in 1 second. In 1 second, how many cycles are made? How many complete cycles are formed? This is one complete cycle. This is second, third, fourth, fifth, and then this becomes sixth. So how many complete cycles are formed in 1 second? That becomes the frequency of the wave. Now SI unit of frequency is hertz. It is hertz, H and small z, which is same as number of cycles per second. So when we say if an object vibrates or oscillates 20 times in 1 second, that means its frequency is 20 hertz, or we can say there are 20 oscillations in 1 second. Velocity is the distance traveled by wave in 1 second. How much distance is traveled by a wave per second? That becomes the velocity, and velocity is the SI unit for velocity is meters per second. So that's all in this video. In my next video, I will be talking about relation between frequency, velocity and time period. So do watch my second video also. Bye for now. Do like, share and subscribe the channel for more such videos. Thank you.